of 90 for this inductor in parallel with 500 ohms at an angle of negative 90 for this capacitor in parallel with 3K ohms, right? Because these three are in parallel once we add these two together. When we get the parallel combination of that, you should get 1.756 K ohms at an angle of negative 54.16. So that's adding these two in series and then in parallel with these two. So really, we only had to redraw this circuit one time. So we have 28.28 is our voltage source. We have 2K here. We have the capacitor of 500 ohms, which is the reactance. And then we have this right here, 1.756 K ohms at an angle of negative 54.16. So you just simply have a series circuit now. So what do we have to do? We have to get Z total. How do we get Z total? By adding this, this, and this all the way up. So Z total, when you add them, and you should be pausing these videos so you can actually calculate them. Okay, so when you get Z total, you should get 3.587 K ohms at an angle of negative 32.42. Okay, we have to get I total now. And remember, I total is E total divided by Z total. And what's our E total? It's 28.28 volts. Z total is 3.587 K ohms at an angle of negative 32.42. So our I total should be, ready, 7.88 milliamps at an angle of 32.42. So that's the current in this circuit. So what do we have to do now? We have to get the voltage drops for these three. Once we get them, we should add them up and they should be 28.28. And obviously this is at an angle of 0. So once we do that, we have the voltage across the 2K, which is VR1, okay, is 15.76 volts at an angle of 32.42, right? Then we take that current and we multiply it by 1.756 K ohms, right? So that voltage drop is 13.84 volts at an angle of negative 21.74. And now we have to do VC1. So VC1 is just the 7.88 times that, right? So VC1 should be 3.94 volts at an angle of negative 57.58. These three voltages should add up to your E total of 28.28. So now how do we determine what's going on next? Well, we only did the series combination here and then these three in parallel. We already have the voltage and current for here, so we're going to bring back this voltage, okay, comes here, 13.84 at an angle of negative 21.74, and here, 13.84 at an angle of negative 21.74, and it goes here, 13.84 at an angle of negative 21.74. Here, this voltage has to be divided by both of these, right? Because there's two, they're in series. This voltage, you can divide by this to get the current. This voltage, you could divide by this to get this current. Okay? This voltage divided by 3K, you can get that current. And then that current you can multiply by each individual because they're not going to have 1384 each. They're both going to add up to 1384 each. So, IL1 is what you need to figure out now. I'll give you a second. Okay, so you should get 21.29 milliamps at an angle of negative 111.74. Does that make sense? It should. Then you have to take this divided by here to get IC2. When you do that, you should get 27.68 milliamps at an angle of 68.26. Okay. Then we can also use the voltage divider rule for these two, right? So if I take E total, this, times 2K divided by 3K, I can get the voltage for this 2K. If we did that, it would be 9.22 volts at an angle of negative 21.74. Oop, that's a little tight. Then if we do E total times 1K divided by 3K, we should get 4.61 volts at an angle of negative 2174. Oof, that's coming close. But if we wanted to get the current for R2 and R3, you can just simply divide this divided by 3K. If you did that, your current was 4.61 milliamps at an angle of negative 2174. Sorry about that. And that's it. You got voltage and current for everything now. This voltage comes back here. This current of 7.88 goes in here. And it makes sense. Okay, talk to you later.